In section 7.1, you use the sine law to solve for unknown side lengths or angles of oblique triangles, but you only if you knew two side lengths and an angle opposite to one of them. Okay. You know what that is saying? For sine law, you need a pair. Right? That's what it's reminding you of. They don't say it that way, but I'm telling you that's what they're saying there. What happens if you want to know a side length or an angle in other situations? There's another trig ratio, or trig law, I should say, which is the cosine law. Okay? With the cosine law, you can solve for the following cases. The third side length of a triangle, if you know two side lengths and the angle between them. I'll give you a diagram, okay? So make sure you write this down. The diagram will look like this. If you have a triangle like this, right? And you know these two side lengths and the angle in between them, that's when you know you're going to use cosine law. This one is called a side angle side scenario. Okay? And then the next way you will know. By the way, is there a pair here? There's no pair. Okay, that's another way of looking at it. You can find any angle if you know the lengths of three sides. Right? If you know the length of the three sides of a triangle. So I'm going to give you another diagram like this. If you have check mark, check mark, check mark, we call this SSS, like that. Side, side, side. Bingo, you know it's cosine law. Okay? Notice that both of them do not have a pair. Okay, note, in both cases, you do not have a pair. There's nothing you can do to get that pair. Okay. Let's go a little further down. So now the formulas will begin. And there's actually a nice pattern that you will recognize. So go to the, like under this diagram here. So assume you have a triangle like that. And we will have the SAS scenario here. If you have an SAS scenario, right, maybe just one more time, triangle like that, where you have the side, the angle in between them, and another side. You will do as follows. Use one color now, so now this is when you start using your colors. Side A squared is going to be equal to, and at first it looks like Pythagorean theorem. So you use red for A squared, then you use your other color for what follows, is equal to B squared plus C squared minus 2 times B times C times cosine, and watch this, now I change my color at the very end, cosine of angle A. I do, yeah. You got you. Nice. Okay. So it's one thing to mention is that side A is across angle A in this scenario. Can you do this? There should be a dot in between all of these. This is saying they're all multiplying each other. It's saying 2 multiply b multiply c multiply cosine a. Okay. Another version of this is if you wanted to solve for side A, right? If you wanted to solve for side B, you go b squared is equal to, so watch this, if b is over here, you're left with which two sides? A and c, right? A squared plus c squared minus, watch this, earlier you had b and c show up here, right? Now you're going to have a and c show up here, so it's minus 2 times a times c times cosine, and now you switch colors, angle B. And the last version of this is c squared, which is going to be equal to, you're using c squared, so you have a squared and b squared left, minus 2 times a times b times cosine of angle C. Yeah, we're on 275. Right. So these are the three versions of the formula, right? Because depending on the situation, you might want to solve for A, you might want to solve for side B or side C. So you have all three different versions of it. Then we'll kind of separate the left side, and on the right side, when you have the SSS scenario, it's check mark, check mark, check mark, all three sides. So if you know all three sides, you're going to have to use these formulas, one of them, okay? And basically what this is saying, you can solve any angle start with the largest angle. If the choice is given to you, you will start solving for the largest angle, and you will see a little bit later why that is, why I'm suggesting you do that. Okay, so it's basically this formula just rewritten. Okay, I'm rearranging it a little bit. So if you wanted to solve for angle A, you would use, I'm using blue to start off, but as long as you use different colors, right? Cosine of angle A is going to be equal to b squared plus c squared, and watch this, it's very important, switch colors now, minus a squared. So I'm letting you know that, right, if angle A is here, then the side across from it will be subtracting at the end here. And now I'm switching colors again, over 2 times b times c. The next version, if you wanted to solve for angle B, you would start with cosine of that angle, which is equal to, now that you're solving for B, it's going to be a squared plus c squared. And now I'm switching colors. What's going to come over here? Minus b squared, side B that is. All over Notice that before we had B and C adding here, and then it came back down here, right? 2 times B times C, see that? So this is going to be 2 times A times C. And the last version, if you wanted to solve for the last angle, and we're using ABC, it will change later on. So just focus on the pattern. Cosine of C is going to be A squared plus B squared, you guessed it, minus C squared over 2 times side A times side B. So side C only shows up once, right? The side across the angle you want only shows up once. And then the rest is whatever is already there. Notice that you're squaring the top, you're not squaring the bottom. Okay? Same here, you're squaring the first two, you're not squaring them here. Okay? So this I would strongly suggest to have one of these on your study sheet. But maybe wait a little bit until you've done a few examples to know what you should or shouldn't have on there, so you're not using up too much space. And now we'll do an example. I think I just wanted to add one more thing here. Yeah, there's one triangle that can never be solved. When you have a triangle where you know all three angles, angle, 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 cannot be solved. There's nothing you can do with angle, angle, angle. You need at least one side to get you going. So if you have at least one side and a bunch of angles, you may use sine law, cosine law, a mix, but only one of them you can use to start. Okay, so this is a big note that you should know. If I throw one like that at you, you should be able to explain this is a three-angle scenario. I cannot solve that one. There's no law that will allow me to solve for that one. Okay. All right. Let's do an example. Are we good with the formulas? We all have them? All right. Let's put them to the test. So we're now you have sine law, cosine law available to you. Obviously, the next couple of examples are all cosine law. I'm telling you that already, no surprises, but I'm still getting your brain to think. Yeah. Anything else works. Anything else works except for angle, angle, angle. Yeah. Calculate the length of side A, so they want this one. That's your question mark. You recognize that this is a side angle side? Watch this, right? You know this side, you know the angle in between them, right? You know two sides. So this is an SAS. What are you going to use for it? You're going to use cosine law. There is no pair cosine law. So watch this. If right now I want to solve for side A, so I use my formula like this. A squared is going to be these two sides in no particular order, but it's going to be B squared and C squared minus 2 times BC, right? So it's the sides that I used and squared times cosine of, it has to be cosine of the angle across from the side you want. Right? You know this angle, you want that side. So another way of putting it is like the only side missing is the one that's across the given angle. And that angle is sandwiched between two sides, so you know it's cosine law. Right? Okay, let's fill in now. This one I won't do every time, just for your first example or two. Okay, like you don't have to write out the formula. So a squared is going to be b squared, which is 7.9. I'm going to square that. This is going to be maybe a learning curve on using your calculators on this one. So 7.9 squared plus 5.2 squared minus 2 times, I like to use brackets, 2 times 7.9 times 5.2, and then just cosine of 43 degrees. And right now I'm going to first just do it in one shot, or I'll break it down. I'll be nice today. Let's figure out what this is first. So grab your calculators and just, I have an x squared button. Like on my calculator, I have an x2 button right here. You might have to use the hat button. The hat is the power button. So let's say you don't have the x, so 7.9 squared. If you use the hat like that, it will square it for you. But I will use this 7.9 x2 plus 5.9 x2. And I will figure out what that is. Do not drop any decimals. 97.22 exactly. Did I make a mistake? Oh, yeah. Thank you. I'm looking at my key here. It's like, that doesn't make sense. 89.45. I apologize for that. That's why I like these calculators, by the way, because it tells you right away that you made a mistake, right? Okay, let's now worry about this. So you bring this negative down, and we'll figure out what this is. 2 times 7.9 times 5.2 times cosine of 43. Okay, hold on. Some of you have calculators that are not showing you what to type in. You have to do this backwards. You have to go 43 cos times 5.2 times 7.9. You go backwards. If you have one of those calculators, you know who you are. If not, I can help you later on. So this is, we have to use at least four decimals. So 60.088, and that is 0 as well. Okay. Use at least 4 decimals. I will show you that you can do this in one shot. Like you can actually do this all in one shot. You don't have to break it down. But this piece here, this whole thing reduces to just that. And then you go 89.45 minus 60.0880, and you end up with a squared is equal to 29.362. And just like in previous grades, what do you need to do there to find the final answer? Square root, right? I will do this in a lot fewer steps in a bit. Okay, just follow along for now. So I'm taking the square root of my answer. So answer is 5.42 centimeters. There you have it. One more. This one is going to be done in a lot fewer steps. Okay. I'm asked to find this. So I have side, angle, side, right? This is an SAS. Cosine law. In this case, I'm trying to find r squared, so I'm going to go r squared is equal to the other two sides. What are they called? Well, if this is capital Q, this is lowercase q. If this is capital P, this is lowercase p. I know I have to use these two sides here. Order doesn't matter. Just take them both, square them, and then add them. Minus 2 times q times p times cosine of capital R. And notice this. Lowercase r is there. Capital R is there. Okay. There's no other R anywhere in between. So the side you're trying to find should not show up here again. So let's go and plug this in. Q is 4.3. P is 6.5 minus 2 times 4.3 times 6.5 times cosine of 61. And here's where having a good calculator is going to pay off. I'm going to go straight to square rooting and typing all this into my calculator. Okay? So 4.3 squared plus 6.5 squared minus 2 times 4.3 times 6.5 times cosine of 61. I typed it all in one shot, and I should be getting that. 33.6391, and it keeps going. And so all I have to do now is take the square root of my answer, and I get 5.80. That's what it would be rounded, kilometers. That's, see, 4 lines basically. You can do this in 3 lines. You can omit this first step in the future. This is just for you, okay, for your notes. But 1, 2, 3 lines, you're done. Okay? Let's get you to try one right away. Try the 2 questions on 277. Were some of you writing it down still, so I'll leave it there. But try 277 right now. See if you can do it.